In this video, we're going to graph inequalities. So let's take a look at our first example. It's asking us to graph x is greater than 5. So what does that mean? Well, first we have to understand that that's a set of numbers, right? That's a whole bunch of numbers. And we have to somehow write a graph that indicates where those numbers are, okay? So everything greater than 5. So what does that mean? Well, find 5 and just think about it for a minute. Everything greater than 5, well, 6 is greater than 5, 7 is greater than 5, but don't remember all these guys in between as well, right? So all these numbers are greater than 5 going forever. So we have to shade that region in, all right? So I find 5, right? And what we have to remember is how to deal with the endpoints. 5 is the end of that set, right? It's 5 and everything over, or I should say just everything greater than 5. So when we have a greater than only symbol, that gets a parenthesis. When we have a greater than or equal to symbol, we use a bracket to indicate the 5 is included. So in this case, the 5 is not included in the set. So what we're doing is shading everything from that point on. Okay, and I highlight that the arrow at the end indicating that goes to infinity, right? So that's everything from 5 to infinity. Okay. Similarly, if we had the less than, which we'll see a little bit later, a less than guy gets a parenthesis, and a less than or equal to gets a bracket going the other direction. All right, we'll see that in the next example. All right, so next up is interval notation. So the graph really helps me with interval notation because with interval notation, I always start with the smallest number in the set, and that's 5. And I've already considered the parenthesis, so I didn't include it. So I do that. All right, that's the smallest number in the set, parenthesis indicating it's not included. It's just everything just greater than 5. And now I go to the largest. Well, the largest number's down here. However, there is no largest number. It goes to infinity. So I just draw my infinity symbol. And remember, infinity always gets a parenthesis. You'll never use a bracket for infinity because you can't really include it. It's not a number. It's more of a concept. That means go forever. Okay, so that's my answer in interval notation, 5 to infinity. All right, example number 2, less than or equal to 1. So again, just another way to think about it is look which way the arrow is pointing for the inequality symbol. It's pointing to the left, so we're going to be back here. Okay, I'm going to find 1. I'm going to use a bracket, and notice how I open that bracket to the left because I have to go left. Everything less than 1 on a number line, that's everything going this way, right? Just the way that arrow is pointing as well. So that's one way you can think about it. I'm going this way. Everything less than or equal to 1. So because of the or equal to, that's why I'm using the bracket in this case. And I'm going to shade everything from 1 going back. So this is my inequality. Everything less than or equal to 1. This is my graph. And finally, I need to do my interval notation. So again, I start with the smallest number. In this case, there is no smallest number really. It's going here forever. So that's negative infinity. That's where it starts. Gets a parenthesis. And I'm going all the way till 1. That's my biggest number. And I have to include it. So that really, using the bracket on my graph helps me because that's directly related to the bracket in interval notation. So these three things all mean the same thing. 1, 2, 3. All those are representations of the set negative infinity to 1, including 1. All values less than or equal to 1 is just another way to say that. Okay? Moving on. Greater than negative 4. So again, I consider the way that guy's pointing and the underscore meaning negative 4 is included. So everything's going to the right. So I use a bracket. And then I'm going to infinity, so I just graph everything going to infinity. All the numbers that are greater than negative 4, which are all those numbers that I just graphed. Okay, that's the second way to represent that set. That's the first way, that's the second way, and now interval notation. Well, we have the bracket, so that's good because it's already given. I put the smallest number to the left, which is negative 4. That's the smallest number in my set. comma, and then the biggest number. Well, there is no biggest number because it goes forever, so I use the infinity symbol. Okay. Just another note, sometimes I see these get mixed up. If you're using positive infinity, it'll always be on the right. If you're using negative infinity, it'll always be on the left. So like, let's jump back to number 2, for example. You never do something like this. Sometimes I see this, right? Just at a quick glance, I know that that's wrong because it's backwards. Negative infinity will never be on the right. Negative infinity always has to be in this position. Always, always. So just kind of make note of that. If you do need to use negative infinity, if you have a less than inequality, it's going to be on the left. If you need to use positive infinity with a greater than inequality, then it's going to be on the right. Okay, so those 3 examples made use of infinity. Now we got to look at 2 that do not, or I'm sorry, 1 that does not. Number 4 will not have infinity in it, and I'll explain why in a second. But 4 and 5 are called compound inequalities, so they're a little more complicated in that they have 2 conditions on the x. Let me scroll back up here. You see, for number 1, 2, and 3, there's just one condition. X had to be greater than, X had to be less than or equal to, X had to be greater than or equal to. But now I have 2 conditions for number 4. If I try and read this, this is reading X is greater than -1 and less than 5. If I try to read it in terms of X, I know this one's a little backwards. I got to read that backwards. X is greater than, right, because it opens with the bigger side with the X, greater than -1 and less than or equal to 5. So how I think about these guys is that the set, all the possible X values are in between -1 and 5, in between. So I find -1, there's no underscore there. So I draw a parenthesis. I find 5, there is an underscore here. So I draw a bracket. And that's the graphical representation of that inequality. That right there is where X lives, in between -1 and 5, right? If I were to read this inequality that was originally given, let me clean it up a little bit. X is greater than -1, less than or equal to -5, right? So that's all these values, erase them, all these values right here. That is the graph. Okay, and that really helps me with interval notation. Remember, interval notation, start with the smallest number on the left and go to the largest number in the set. And I'm using the parenthesis for the 5 because it's included in the set. The -1 is not. Okay, so that's a lot different than our previous 3 examples because nothing's going to infinity. X is bound between 2 values. All right. And finally, one more number. If you look at number 5, it looks a lot like the first 3 examples with the word or in between. So basically, I'm just graphing 2 sets on one number line. And then we'll have to really think about the interval notation. So treat this as 2 problems. X can be less than -1 or greater than 2. All right, so where's -1? I should say less than or equal to -1. It's right there. So I graph everything going to the left as the arrow indicates. That's X, that's this set right here. Let's use green for the other set. X is greater than 2, so I find 2. 2 is not included, and I graph everything to the right because that's greater than. All right, so that's the graphical representation of the given inequalities. All right, so we got the inequality notation or set notation, we got the graph notation, and now I just have to do my interval notation. So we've done these individually, so we just got to bring them together. Start with, for the blue set, start with the smallest value, negative infinity, go to the largest value, -1, use a bracket, because I did when I was graphing. Always use a parenthesis for infinity. Now do what I graphed in green. This is one answer now. I'm not saying it's 2 separate solutions. It's one solution. We got to bring together the 2 sets, the 2 inequalities. Start at 2 and go to infinity. Okay, and like I said, it's like 2 problems in one. We just need one symbol that you should have seen before, and it combines the two sets. It says it could be in this set, or it could be in this set, and it's a union of the two sets. So it looks like a big U. And that's how I say it can be in this set or this set. Okay. And that's your answer. That's the third representation of that set in interval notation.